Howdy everybody, this is Hotard here. Welcome to my first Algebra 2 4th 9 weeks instructional video. I will be posting 3 of these a week on Moodle for the remainder of the school year. Before we begin though, apparently the thing to do for old people these days in honor of our class of 2020 is to post pictures of themselves when they were seniors in high school. So as a special treat for those of you tuning in, I give you, from my glory days, Mr. Hotard when he was a senior in high school.
Here it is. Look at that guy. Voted most likely to succeed at life, and that's been pretty much true. So now, fun stuff's over with. I hope you enjoyed that. Now on to the math. Today's lesson should look pretty familiar. This is actually the last lesson that we did of the third 9 weeks. We're just going to today review logarithms. Tomorrow we'll be starting some new information. But I posted these notes on Moodle. You should be able to print a copy or just do this on loose leaf paper. Today we're just reviewing, we're going to be rewriting exponential equations in logarithmic form and vice versa. We're going to be evaluating logarithms with and without a calculator, and we're going to be using the inverse properties of logarithmic and exponential functions. Now, important thing to remember about logarithms. Logarithms are always equal to exponents. Logarithms equal exponents. They do the same thing exponents do. They follow the same rules exponents follow. So first thing we're going to be doing is just how do you change from one to the other. You notice right here, 5 to the third equals 125. That is true because 5 times 5 times 5 gives you 125. That is an exponential form. Over here, log, we call this base 5 of 125 equals 3. This and this mean the exact same thing. It's just two different ways of saying the same exact thing. This 5 over here, we call this the base. You notice the base over here with the log, it's a little number right here. And then back in exponential form, this little number right here, this 3, that's an exponent. Now where's the 3 over in the log form? It's not over here, it's over after the equal sign. The exponent's over here after the equal sign because logarithms always equal exponents. And then over here, this 125, we'll just call this the solution. You notice that's right here. In the log form, it's right here next to the base. So everything kind of gets switched around. So first thing we're doing is just rewriting from one to the other. So if you look at problem number 1, 4 to the second power equals 16. All right, I just want to rewrite that with a log. So I'd say log my base, which is 4, so just a little 4 right there, of, now it's either of 2 equals 16 or of 16 equals 2. Remember, it's got to be equal to the exponent, so of 16 equals 2. That's my log form. Base, solution, and then the log is always equal to the exponent. So problem number 2, same thing. Now you notice this negative exponent. Y'all remember what negative exponents do? They make it a fraction. So 9 to the negative 1 equals 1/9. Rewriting that in log form, log, which one's the base? 9 of negative 1 equals 1/9 or of 1/9 equals negative 1? It's log base 9 of 1/9 equals negative 1. So that's rewriting. Now, next two problems are doing the exact same thing, just in reverse. I gave you the logarithm. We're rewriting it without the log in exponential form. So here, the base is 7. The exponent is negative 2, and it's equal to 1 over 49. 7 to the negative 2 equals 1 over 49. And problem number 4, log base 6 of 216 equals 3, just rewriting that. So again, that's going to be base is 6, exponent is 3, and it's equal to 216. 6 to the third power equals 216. Now, I also posted on Moodle, in the same section, I posted 6.3 practice A. It'd be a good idea right now to pause the video, open that up, try a few of the problems up on top, and then look at the answer key that's also posted, see if you got them right. All right, did you do them? Great. So now that you could rewrite between exponential and logarithmic form, now we're going to look at our second important thing, evaluating logs. Now, some of this you can do in a calculator. You notice on your calculator there is a log button right here, kind of next to the 7. All right, and then right underneath that there's a button that says LN right next to the 4. These are the two log buttons. We're going to talk about that. Now, if you're just hitting the log button, there's no base. So if you just have log with no base on it at all, that means the base is automatically 10. log with no base at all written means it's log base 10. So if you hit the log button on your calculator, you type in log base 10. Also, right underneath that, I told you there was an LN button. That's also a log button. That stands for log natural, or in English, it's natural log. That's log base E. Now, not the letter E now, the number E. The base of natural log is the number E. Remember, we studied that right before the coronication, I guess you can call that. That's the number E is about 2.72. We use that in problems with compound interest. All right, so these are the two types of logs the calculator can do. So if you look at problem number 5, log of 1,000, now that one doesn't have a base written. So you remember, what's the base on that log if they didn't write the base? It's 10. So that's like saying log base 10 of 1,000. Now this one, yes, I could just type this in my calculator, log of 1,000, and it would tell me the answer. But I don't need the calculator for this problem. I could figure it out. Because when it says evaluate, it's just asking what is the exponent. This is like saying 10 to the what power gives me 1,000. All right, and the answer is 3, because 10 to the 1 gives me 10. 10 to the second, 10 times 10 is 100, and then times 10 again will give me 1,000. So the answer is just 3. Now the answer is not 10 to the third power. The answer is just 3. It is the exponent. So problem number 6, log base 4 of 1/4. Again, this is asking me 4 to the what power gives me 1/4. All right, now you remember what type of exponent changes the problem into a fraction. It's a negative. So 4 to the negative 1. The answer is just negative 1. Now, if that had been like 1 over 16, then the answer would have been 4 to the negative 2, because 4 squared gives you 16, and then the negative exponent would flip it and make it a fraction. So the last problem right here, log base 9 of 81. Again, that's like saying 9 to the what power gives me 81. All right, and the answer is 2. It's not 9. 9 times 9 gives me 81, so that means 2 9s, so 9 to the second power. The answer is 2. So that's evaluating logs. Again, this would be a really good point to pause the video, go to that 6.3 practice A page. The middle section is all about evaluating logs. Try a few of those problems. Check the answer key when you're done. Make sure you did them right. And then come back and we'll do the last part of the video. All right, and then the last thing we're going to be doing, just on the second page, is we're going to be using, it's called inverse properties of functions. Now, if you remember, a lifetime ago, it seems like, when we were in school, we were doing this a while back. We were finding the inverses of a function. All right, the first thing you had to do to find the inverse of a function, you had to do something with x and y. You had to switch x and y. Switch x and y, then solve for y. Switch x and y, then solve for y. Remember, this was to find the inverse of a function, the opposite function, a function that undoes what the other function does. Now, in order to do that on these types of problems, when you're dealing with exponential functions and logarithmic functions, after you switched x and y, in order to solve for y, you need to rewrite in the other form. Write yourself a little note. Rewrite in the other form. That means if the problem's in exponential form, you need to rewrite it in logarithmic form. If the problem has a log, you need to rewrite it without the log after you switch x and y. So if you look right here, problem number 8 asks us to find the inverse of this function. Now f of x, remember, that's just a fancy name for y. So this is like saying y equals 6 to the x. I want to find the inverse, the opposite function of this. So my first step in every inverse problem is to do what? Switch x and y. So I'm going to rewrite this as x equals 6 to the y. I just switched x and y. That's not 6y now, that's 6 to the y power. So now I want to rewrite this to where I have y by itself on one side of the equal sign. So I'm going to rewrite this in log form. So what I'm going to do is I'm going to do the exact same thing I did on the first set of problems. How I had exponential form and I just rewrote it in log form. Now what's confusing for some people is it's written backward. The problem we're doing is written backwards from how this is written. So you might be a little less confused if you think of it as 6 to the y equals x. All right, now I'm going to rewrite this in log form. So I'm going to say log base, which one's the base? 6 of, now remember the log's got to be equal to the exponent. Y is the exponent, so it's going to go after the equal sign. So log base 6 of x equals y. Do I have y by itself? Yes, I do. So that is my inverse. Y equals log base 6 of x. That's the inverse of y equals 6 to the x. Now, same thing. Number 9, just kind of the opposite. First of all, I'm seeing ln. Remember, that's log base what? Not 10. It's base e. The base is e. And this time, first of all, my first step, before I do anything fancy, I need to switch x and y to find the inverse. X equals natural log ln of x plus 3. Remember, that's like log base e. You don't have to write the e, but I'm going to write it just so I don't forget it. Now, whoop, y. So let me, x equals natural log of y plus 3. All right, and then now, I switched x and y. I'm going to rewrite it in the other form. This time I have a log. I'm going to rewrite it without the log. I'm going to do kind of like I did on problems 3 and 4 on the front. How I had the log, and I rewrote it in exponential form. Again, the problem's written backwards from the way these are written. So it might be a little bit more helpful if we just flip this around. Natural log, so like base e of y plus 3 equal to x. And so I'm just going to rewrite this without the log. All right, so here's my base. Base is e. Which thing is the exponent, the y plus 3 or the x? The x, e to the x equals y plus 3. I rewrote it without log. Now, I'm not done though, because do I have y by itself? No, I need to get y by itself. I need to get rid of the plus 3, so I'm going to subtract 3. So my final answer, I'll just write over here on the side, y equals e to the x, and then put a minus 3 at the end. That is my inverse. That is the inverse of y equals natural log of x plus 3. All right, now the last thing in this part, it looks tricky, but it's actually the easiest thing on here. All right, first of all, 10. It's asking me to simplify 10 to the log of 4. Now, they didn't put a base right here on this 10. Remind me again, what's the base if they don't put the base? Is 10. Now, the nice thing about these inverses, since exponential functions and log functions are inverses of each other, they undo each other. So the nice thing about this, 10 and then exponent log base 10, they just cancel each other out. What's the only thing left in the problem? It's 4. The answer is just 4. The 10 and the log base 10 cancel. The answer is 4. And then I'm going to do the same thing with number 11, but slight problem though. You notice log base 5 and 25, they're not the same. So I can't just cancel these and say the answer is x. I need to have the same base. So let's just rewrite this part of the problem. 25 to the x, let's just rewrite that as 5. That's 5 to the what power? To the second power. So this is like saying log base 5 of 5 squared, but then I also have this x exponent, so it's really 5 to the 2x. So now, using the same thing I did over here, it doesn't matter whether the log comes first or the base comes first, but I have log base 5, and I have 5 with an exponent. They're going to undo each other. So my answer is just 2x. All right, so again, they cancel out. I need to change 25 into 5 to the second power. You have to have the same base in order to apply that property. And then log base 5 and 5 cancel out. The answer is just 2x. It's what's left after you cancel these. And that is everything for today. Make sure you try in all the problems on that 6.3 Practice A page. You can check your answers on your answer key. If you have any questions, feel free to email me. You'll have my email address. I check my email regularly in between 10 and noon every day. You can email me anytime, all right, and I'll get back to you as soon as I can, but you'll get a quick answer if you get to me between 10 a.m. and noon. All right, let me know if you have any questions. If you just want to send me a picture of your work, say, Mr. Hotard, I did something wrong. I can't figure out what I did wrong. Feel free to ask me about that too. All right, or just let me know how you're doing. All right, I need something to do that doesn't involve my own children. Okay, it's great talking to y'all. I'll be back with you tomorrow. We'll be getting into properties of logarithms. Have a great day.